Hello everyone, back again with a bit of a simple one this time. We're going to be achieving persistence on host via server message block traffic within Autorun Registry keys. And the reason that we're going about this method is specifically because a more recent vulnerability, CVE 2023-23397, or in other words, the Outlook vulnerability, used a very similar method in order to harvest user credentials. The short version of this exploit is Outlook, using a specifically crafted message, would create outbound SMB traffic to a command and control server, sending over the user's NTLM credentials, or more specifically, NTLM v2. Now, while we aren't going over this exploit specifically, this persistence method uses the same general exploits and traffic that we would be seeing. And thankfully, it's actually fairly easy to perform. We only have two requirements. First, that we have local admin access to the host, and second, that the domain actually allows external SMB traffic and it's not blocked at the firewall. And the reason that this is so valuable as a persistence method is it doesn't use anything other than native Windows binaries, so there's no malware detections. And second, it's unlikely to generate any alerts from EDR tools. I know specifically Palo Alto XDR has a alert for Autorun Registry keys modified that would catch this. However, tools like CrowdStrike Falcon, SentinelOne, Carbon Black, a lot of these other typical tools that you might find within the cybersecurity space genuinely would not fire an alert on anything that we do, with the exception of perhaps some commands we run in order to weaken security posture on the host. Now, there's only really two steps to this. The first is that we're going to create a logon script, just a batch script, and we're going to add it to the Autorun registry keys. That way, any user who logs in will automatically run this script every time they log in. And the second is that we're going to connect to our external SMB share. This means that, putting these two together, any user that logs into the device, regardless of when or where they change their password, will always send to us, as long as the script is still on the host and it's still in the Autorun registry keys, will continually send us their NTLM version 2 hash indefinitely, at least until they block our command and control server's IP at the firewall or they turn off external SMB traffic connections in the domain settings. Alright, so let's assume we have local administrative access to our compromised Windows device. We also have a open SMB share running on Kali that accepts any username or credentials whatsoever. Now, if you're looking to perform this test on your own, you may have to make security posture modifications to your compromised device, modifying two registry keys, HKLM system, current control set, yada 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 parameters, allowing insecure guest authorization, as well as manually adding a value of 0 to this same key. Essentially, what we're doing is we're telling the host, hey, allow insecure guest authorization to SMB shares. Now, in order to manually connect and perform this exploit, just as a proof of concept, anytime you connect to a remote share, in this case, it's an internal IP, obviously, and using the percent signs on both sides of the username, this is going to automatically fill out the currently logged in user. Now, I'm currently under the vagrant user, which you can see right here. I've just spawned an admin level shell for now, just for testing. So we can see command completed successfully. We can go over to Kali, and we can see our vagrant user with some entropic data and then a password salt has sent their net NTLM version 2 hash straight over to us. And if we confirm this by copying this and then adding this to a hash file and confirming with hash ID, we can see this is indeed a net NTLM version 2 credential type. This means if we were to brute force it, we could see, hey, the vagrant user's current password is vagrant. Makes sense, right? Now, we only have one connection to this, and while sending credentials of a currently logged in user is somewhat helpful, for example, if you want to do pass the hash or overpass the hash or pass the ticket even, what we want in this case is to establish persistence. So, I'm going to disconnect from this share real quick. And what we're going to do is we're going to create a batch script that's going to run 3 commands for us. It's going to run the same netuse command with 10.0.3 in our share and our username. Again, this is hard-coded, so this really should be going through a loop of a whole bunch of different IP addresses, but we'll keep it simple for now. Then we're going to ping the local host 4 times, essentially stalling for 3 seconds. And then we're going to disconnect from the share by using netuse delete. So essentially, in order, we're going to connect to the share. We're going to wait for 3 seconds, and then we're going to disconnect from the share. Very simple. And I've named this script persistence.bat, just for ease of use, located on this user's desktop. Now, if we're going to add this to the Autorun Registry keys, we'll have to use this command, and breaking it down, this is essentially saying, hey, add to the local machine under the Autorun Registry keys our persistence script, again, just for ease of use, right? And it's located here. Now, ideally, if you want this to be used by every user, you would have this script under, say, program files, or perhaps you would name it as Internet Explorer Update, something like that, something that looks benign, right? But in this case, we're trying to be as obvious as possible. So, if we restart this computer, we should see another connection to Kali. And as you can see right here, we only have one connection, the one that we did manually, and we should receive another one here in just a sec. Alright, so the user just logged in. Give it a little bit. This thing only has 2 gigs of RAM, so it's trying its hardest. And we should see this persistence batch script automatically run on its own. I haven't done a Windows style hidden, or I haven't hidden any kind of execution on this. There it is. A user vagrant, it connected the share, it waited, and it disconnected. And confirming on Kali, we can see, yes, indeed the same NTLM version 2 hash, sorry, this is the salt right here, from right here is the exact same, just because we haven't changed the user's credentials. However, what this means is that we have established successful persistence on this device, meaning that if any user logs into this device, say the vagrant user or a local IT admin, anyone that locally logs into this device will send us their NTLM version 2 credentials, at least until they block us at the firewall or block external SMB traffic. Alright, so this detection comes in 2 parts. First, we're going to be looking for modifications to the Autorun Registry keys associated with our persistence script. And second, we're going to be looking for unexpected SMB traffic. So first we're going to focus on the HKLM and HKCU keys for run and run once. Technically, you could keep this fairly generic and saying run and then anything following that, because there are legacy registry keys, run services, and also run services once, specifically on Windows 7 and older devices. So we'll keep this fairly generic. However, we can see if we go for event code 4688, which for a refresher, that is essentially whenever process A spawns process B, we can see CMD spawning registry to make modifications to this script. However, this is a little bit too generic for our purposes. We could, in fact, add some kind of command line interpreter saying, hey, make sure it's to this specific key. However, we don't really have a value for it. Even if we look through our Splunk over here, I don't know why that's not collapsing. Even if we look over here, we're really only getting information on what process was spawned, which this doesn't really tie down to what we need it to be, right? So instead of the usual 4688, let us change it to 4657. 4667 is a event code that you have to turn on manually, essentially letting you know anytime a registry key was changed. This is much more granular for what we want because we can see in the object name right here, we actually have reference to the key that we're looking for, which is much better for our detection purposes. So much so that we can even add our object name right in here, where we're looking specifically for either HKLM or HKCU. Really, it's going to be either of those two, realistically, as well as run once, run services, or run services once. This should be generic enough to catch all of it. Now, if we get rid of the persistence here, just get rid of our little cheat, we should still come up with our two events. And we can see right here where it's populated, we have our host name, we have our registry value that was modified. We can see it's the Autorun Registry key here that we were expecting. We see the script name, or the value that we put in with CMD originally. And, even better, if I can find it... there we go. We even have the location of our malicious script, which is perfect for detection. Moving on from our Autorun Registry script detection, let's go ahead and check our firewall logs to see if we can find our suspicious SMB traffic. So I'll add a little cheat in here. Since we know what the hard-coded IP address for Cali is, we can just throw that in. And we have 344 events. But this is all traffic, not necessarily helpful. Why don't we tie this down to specifically what port we're going to, the destination ports for SMB specifically. And we can throw in... Whoop. I did that twice. Goodness gracious. And we can see specifically 200 events, which is much leaner, specifically to SMB traffic. Now, if we're looking for an external host, we're going to be modifying this path variable right here, essentially where it's showing, hey, here's the actual destination and the share name. But according to ye old ChatGPT, we can modify our regex to say, hey, essentially anything outside of an internal CIDR range, the 10 CIDR, 172 CIDR, and the 192.168 CIDR. Now, obviously this isn't going to show anything because Kali's being hosted on an internal IP to begin with, but just for fun, if we modify this to be our internal 10.0 CIDR, even getting rid of our little cheat code here, we can still see a lot of traffic to Kali's SMB share. And once again, thank you all for joining me on this, and I really hope you learned something. Stay tuned.